in this curved space-time that the bodies themselves create. And that produces the effect of motion that would be described very approximately by Newton's theory. So it reduces to Newton's theory, but it has some, it explains a few other things. In fact, it explains this anomaly that was known already in Einstein's time to do with the planet Mercury. Also famously, it predicted the bending of starlight by the sun. And there was an expedition in 1919 to test that by Arthur Eddington, a British astronomer who went out took an expedition out to the Sahara you need an eclipse of the sun in order to measure that. And he came back announcing that Einstein was right. And Einstein, in fact, Einstein's fame basically dates from that point, 1919. He was not a household name until 1919. Of course, when Eddington came back from his expedition and he announced that Einstein's theory is right, all the reporters came up to him, rushed up to him. One of them asked him, Professor Eddington, is it true that only 3 people in the world really understand Einstein's theory? And Eddington replied, well, who's the third? He wasn't very modest. Well, in addition, there are a lot of small deviations from Newtonian theory, and in fact, you need them. Every time you get in a taxi, you're using Einstein's, well, or rather the taxi driver is, using Einstein's theory of general relativity, because, which is what his theory of gravity is usually called. Because, in fact, these small corrections are actually essential for the global positioning system that's used in all of these devices. So nowadays it's really in everyday use. It also predicted some new phenomena, and one of them in particular is gravitational waves. Astronomers are still out there looking for gravitational waves, but there is very, very good indirect evidence for them, which I won't bother mentioning here. But I will come back to this point about gravitational waves and as one of the predictions later on in the talk. Now, I come now to, you see, those are the 2 big names. But there's a very awkward point, a very awkward thing about gravity, the fact that it's universally attractive. And this was appreciated first of all by one of Newton's antagonists at the time. He spent a lot of time criticizing Newton's ideas. And so this was Bishop Berkeley, a very famous philosopher. I think he was the origin of idealism in philosophy or something like that, but I'm sure there are philosophers in the audience who know that much better than I do. In any case, he had a very interesting question. He said, Mr. Newton, if gravity is universally attractive, as you say it is, then why don't the stars all fall in upon us? Well, versions of that question have been with us for a long time. Basically, since then, Newton had his own answer to that question. He said, well, if the universe is infinite, then, you see, if things have to fall, they fall to a center. If the universe is infinite, then there is no center. Things can fall locally to some centers, and that will be the sun and various other stars. Actually, that was a rather perceptive remark. But he said that, so the universe is infinite, that explains it. We're really a bit of armchair reasoning here, which has a lot of problems when you start to think about it a bit more closely. Einstein, of course, he had to face exactly the same problem with his theory and he in fact faced it in 1917. And what he said is, well, it's because, of course, by the time we come to Einstein, we're not talking about stars really anymore, because we already know by that time that stars belong to galaxies and move around in galaxies. But you can apply exactly the same argument to galaxies. Why don't all of the galaxies fall in upon us? And Einstein said, well, it's because the universe is filled with some invisible substance. Actually, he didn't use those words, but that's what it amounts to. Usually goes by the name cosmological constant, and the Greek letter lambda is always used for it. And he said, well, it's some substance like this that is gravitationally repulsive, and that will balance the attraction. So that was another piece of armchair reasoning. And meanwhile, the astronomers were actually looking through the telescopes,